This is tutorial 1, question 11. In here we have two parts, part A and part B. Let's focus on part A first. In part A, we are given a linear transformation from 2 coordinates to 2 coordinates, R2 to R2. The following are given to us. The operations first rotate minus 3 pi over 4. A negative value of angle means a clockwise direction. So this is the convention. So if I ask you to move here by theta, this is positive theta. If I want to move down to, let's say, alpha, then this is minus alpha angle. So clockwise means minus value. So the linear transformation first rotate 1 point by here the clockwise minus 3 pi over 4, and second, it reflects along the horizontal axis. We are asked to find the standard matrix T. Remember, the standard matrix T basically says find T of E1, put it as the first column, T of E2 as the second column. The problem is R2, so E1, the standard matrix, the standard input is 1, 0, and E2 is 0, 1 for the first standard basis, for the first standard input vector and the second standard input vector. Alright, let's operate on T of E1 first. E1, remember, is nothing but the first point on the horizontal axis here, 1, 0. We are then asked to rotate minus 3 pi over 2, which is in here 135 degrees. We land on the point 2. We are then asked to reflect along the horizontal axis. We reach P3. Remember that in this clockwise rotation, the length of the vector does not change. When we reflect, the length of the vector does not change as well. And because when it reflects, we know exactly the angle, so we can calculate exactly where is P3. So P3, you can find it as this point, which is minus 0.707 along the x-axis and plus 0.707 along the y-axis. So we have to figure out T of E1. Let's try to find T of E2. E2 is the second vector, which is 0, 1. So 0 is here, 1 is here. The second E2 is at this point. We name it as P1. Remember that we are first rotating clockwise, this minus 3 pi over 4, we reach P2. We are then asked to reflect along the horizontal axis. We get this point we call P3. We read off the coordinates is 0.707 plus and plus 0.707 for the second entry. So now we have TE1 and TE2. All we need to do is to put it in here. So this is TE1, this guy is TE2, and this is the standard matrix for the transformation we have just described. Thank you. Right, now we go to the second example. The second example is similar. We again have T2 to T2, R2 to R2. We're asked to reflect across the x-axis first, and then we are reflecting across the line y equals to x. So this is the line y equals to x. Alright, let's start with the first E1. In the first E1, we are first asked to reflect across the x-axis. Because he's already sitting at the x-axis, he's 1, 0. When he's reflecting across the axis, he remains as exactly 1, 0. He's then asked to reflect across the line y equals to x. It basically brings it here. So P2 becomes P3. The length is still 1. So what happened is that transformation of E1 becomes 0, 1, which is exactly E2. What about E2? Right, whereas here, we are first asked to reflect across the x-axis. This is the x-axis, so we are at point 2. We're asked to reflect against this line. here, y equals to x, so it brings us here. So P1 basically changed to P3. We read off P3, the coordinates is -1, 0. So we have T of E1, we have T of E2, and you can see that actually, if you look at it very carefully, you can think of it as a rotation in the anti-clockwise direction by 90 degrees, both for E1 as well as this is E1 as well as E2 here. Right, that's it. Thank you.